All right, space adventurers. Today, we're diving into one of the universe's biggest mysteries, black holes. Ready to bend your brain with some space-time fun? Let's go. Black holes are some of the strangest objects in the universe. Unlike planets or stars, black holes do not have a surface and cannot easily be directly observed. Instead, black holes are studied by the effects they have on the matter around them. A black hole is a celestial object with a gravitational pull so powerful that nothing, no matter, no energy, not even the fastest thing we know, light, can escape. That is why they appear so dark. The boundary around a black hole past which nothing can escape is called the event horizon. The mass of a black hole determines its gravitational force, which in turn determines the size and shape of its event horizon. The more massive a black hole is, the larger its event horizon will be. Fun fact, despite the name, a black hole is not empty space. Instead, an incredible amount of matter is packed into a very small area. To understand how much material we are talking about, imagine a star 10 times more massive than the Sun, compressed into a sphere the size of New York City. That's a lot of cosmic weight in one tiny spot. But how do we know black holes exist if we can't see them? One way is to look for their effects on nearby objects. For example, when a star passes too close to a supermassive black hole, it can be pulled apart by the black hole's powerful gravitational force in a process called tidal disruption. Scientists can also look for traces of gas and dust that have been drawn towards the black hole, or for stars that appear bent or distorted by the immense gravitational forces near the black hole. Question time. What happens when a star gets too close to a black hole? A. It becomes a black hole. B. It gets pulled apart. C. It turns into a planet. D. It disappears. Have you selected the option B? It gets pulled apart. Yes, folks, right answer. Moving on. When a black hole swallows up a nearby star, it can create a powerful jet of energy that can be detected from great distances, called a quasar. The gravitational forces of black holes are so powerful that they can distort both space and time. In fact, scientists believe that time will slow down when you are close enough to a black hole. This is because the gravitational force of a black hole can curve space-time, making it possible for objects to travel through it in a way that bypasses the normal rules of time. For a star to become a black hole, it must be several times more massive than our Sun. When this huge star dies, its core collapses, triggering a supernova explosion. The explosion of the supernova blasts leftover material from the star far out into space. The collapsed core that remains becomes a black hole. Question time. Multiple choice. What triggers the creation of a stellar black hole? A. A supernova explosion. B. A star cooling down. C. A star turning into a planet. D. A star merging with another star. Have you selected the option A. A supernova explosion? Yes, folks, right answer. It is believed that there might be millions of these stellar black holes in our galaxy alone. The black hole at the center of the Milky Way is known as Sagittarius A, with a mass 4 million times that of the Sun. Although black holes have been predicted for centuries, the first black hole was not discovered until 1971. Black holes have since become an important area of study for astronomers and physicists alike. So to wrap it up, we learned about black holes, their mysterious nature, powerful gravitational pull, and how they can distort space and time. And remember, even though we can't see them directly, we know they exist because of their powerful effects on nearby objects. This is another video brought to you by Goalie, the best kids tablet.